Right, let's get into it. Welcome to this explainer, where we're going to unpack one of the most fundamental yet incredibly powerful concepts in computer science. Have you ever stopped to wonder how a totally inanimate machine, a computer, actually seems to make smart choices? I mean, making decisions is just a normal part of our everyday lives, right? We weigh different factors, we look at the rules, and we pick a path. Well, programming is really just translating those real-world human decisions into computer logic. So today, we're tracing the evolution of code efficiency, and specifically, we're looking at how to master a core concept called selection.
Here is what we're covering today. First, the need for selection. Second, the basic if statement. Third, handling multiple decisions. Fourth, the case statement alternative. Fifth, complex Boolean conditions. And finally, choosing the best approach.
Let's start with part 1, the need for selection.
Think about walking up to the entrance of your local grocery store. That automatic door magically slides open for you, right? But it stays firmly shut when nobody is there. So how does the system actually know to do that? It might look like the system is making an active, conscious decision on the spot, but the reality is way more structured. It's been logically designed to complete a very specific process based entirely on the input it expects to receive.
And that brings us to our core definition. In programming, this exact concept is what we call selection. Selection basically allows a programmer to write code that can follow completely different paths of execution. The exact path the code takes is determined by what we call criteria. You can think of criteria as the electronic equivalent of the factors that influence our own human decisions. When a system evaluates these criteria, it results in a condition that is quite simply either true or false.
Moving on to part 2, the basic if statement. When you map this logic out visually, it becomes super clear. In flowcharts, a decision is always represented by a diamond shape. Right in the middle, you have a question. Presence detected? The code is providing a condition to evaluate here. If the outcome of that is true, we follow one specific path, open door. But if the outcome is false, we follow the else path, which is closed door. This is the visual representation of an if statement. If a presence is detected, then open the door, else close it. It's incredibly straightforward for sure, but it really does form the absolute backbone of all computer logic. Now, to actually test those conditions in our code, we rely on logical operators. You're probably pretty familiar with these from math class. We've got is equal to, is greater than, is less than, and so on. Let's apply this to a real-world scenario, like calculating the cost of a train fare. If you want to give a discount to children, the system needs really precise criteria. We would use the less than operator. So if passenger age is less than 16, then apply discount. And using the correct operator is absolutely crucial here. If you accidentally use less than or equal to 16, an actual 16-year-old gets a child discount that they probably shouldn't be getting. Let's look at part 3, handling multiple decisions. So what happens when a single criterion just isn't enough? Let's say you're writing a program that takes 2 numbers and has to output whether the first number is larger, the second number is larger, or if they are exactly the same. Suddenly, we have 3 distinct paths to choose from, but a standard if statement only has 2 exits, true or false. Enter our first real hero tool for handling this kind of complexity, the nested if statement. To avoid the massive inefficiency of writing totally separate sequential if statements that just check every single thing one by one, we can literally place one if statement entirely inside another. And this cascaded logic works beautifully. If we trace the decision points here, we check the very first condition. Is number 2 less than number 1? If that turns out to be false, we don't just stop the program. The false path elegantly routes us right into the input of a second decision point. Is number 2 greater than number 1? By chaining them together like this, the second if statement only ever executes if the first one actually proved to be false.
Now, you could technically just write a bunch of standard if statements, one right after the other. But we call that sequential ifs, and honestly, it's just bad practice. If the very first condition happens to be true, the computer still wastes processing power checking every single subsequent statement, even though we already have our answer. Instead, we use nested ifs, or their much cleaner cousin, the else if statement. An else if allows multiple conditions to be checked within a single block of code. Crucially, the very second it finds a true condition, it executes the code and it skips the rest. It literally stops checking. It's way faster, and for you as a programmer, it's significantly easier to read and indent cleanly.
Which brings us to part 4, the case statement alternative.
Take a look at the routing logic here. Notice something slightly different? Instead of a diamond that only gives you two paths, this setup beautifully routes a single variable into multiple possible branches, like A, B, C, and even a default otherwise path if nothing matches. This is what we call a case statement. So the real trick is knowing exactly when to use which tool. A nested IF or an else if statement is incredibly flexible because you can check completely different variables at every single step. But if you are just tracking one single variable that has multiple possible values, like a user typing A for add, S for subtract, or M for multiply, a case statement is vastly superior. It saves you from having to type out if choice equals A, else if choice equals S, else if choice equals M, over and over again. Case statements save you time, they are much simpler to code, and they drastically reduce the cognitive load for anyone who has to read your program later.
Next up is Part 5, Complex Boolean Conditions. Let's ground this in a real-life example. Imagine you're programming a fire alarm system. You obviously don't want it to go off just because it's a hot summer day, but you absolutely do want it to activate if it detects the presence of smoke or if it detects an abnormally high temperature of, say, 70 degrees Celsius. The condition here requires two totally distinct criteria, and if either one of them turns out to be true, we need the system to take action. To actually build these complex conditions, we use Boolean operators. You can think of these as the physical logic gates of the programming world. First, we have AND, where every single connected criterion must be true for the whole statement to evaluate as true. Then we have OR, where only one of the criteria needs to be true. This one is perfect for our fire alarm, if smoke detected equals true or temperature is greater than 70. And finally, we have NOT, which we use when it's just easier to define the rule negatively. For example, if not input equals 6, which basically means we will accept literally any number as long as it isn't a 6.
The real beauty of Boolean operators is just ultimate efficiency. Without them, you'd be forced to write clunky, deeply nested IF statements just to check two simple things at once. With Boolean operators, you can connect your criteria and evaluate the whole shebang in one single, elegant line of code. Just keep in mind, connected criteria using Boolean logic can only be used with IF statements. That's because a case statement, as we saw earlier, can only ever test one single variable at a time.
And finally, Part 6, Choosing the Best Approach. What you really need to take away from all of this is that as a programmer, you have plenty of options, but choosing the right option is exactly what separates good code from great code. So here are your golden rules of thumb. If you have a simple scenario with only two possible paths, just stick to a basic if-then-else block. If you've got multiple paths that rely on complex criteria or several different variables, that's when you pull out an else-if or a nested-if statement. But if you have multiple paths that are all determined by just one single input or variable, always opt for the case statement. It is going to make your code remarkably easy to read. At the end of the day, programming isn't just about getting a machine to spit out the right answer. It's about getting to that answer in the most efficient, logical way possible. You now have the absolute blueprint for mastering selection. So I'm going to leave you with this. As you sit down to design your next algorithm, will you settle for the clunky sequential path of least resistance, or will you engineer a truly elegant evolution of logic? Thanks so much for joining me on this explainer, and happy coding.